Alright, now that many groups are about to get through task 1, the spinning sign in our programming builds, we're ready to start task 2, or at least be introduced to it. Task 2 is going to be called the Robot Drag Race, and I've provided you with a handout on this. The mission or task description, your team's challenge is to create a robot that can cross a 20-foot distance in the least amount of time possible when a push button switch is pressed to start it. You can race multiple robots built by other teams against each other or play against the clock and keep track of your time to see which team designs and builds the fastest robot. A bonus to this is to program your robot dragster to stop as soon as it crosses the line at 20 feet. Duty titles and description. The mechanical engineer, you must design a robot that will optimize drivetrain acceleration in a 20-foot distance using no more than 2 motors. If the robot is geared too fast, it will accelerate slowly, which will cost it time. There is a balance between acceleration and top speed that each team must find. Experiment with the different tires and gears available with the VEX kits. I'm not going to require that you sketch your solution on a lab sheet, but when it comes to turn-in lab sheets, you will need to identify motors and sensors. The electrical engineer should assist the mechanical engineer in the placement of the motors and sensors. Once the components are placed, connect the motors to the cortex using the attached wires. Make sure to complete this wiring diagram on the lab sheet. The computer engineer, while the other engineers are busy working, you must write a program that will propel the robot forward as quickly as possible. Make sure that you open the PLTW template that we used in our test bed and spinning sign and save as drag race to your student folder. Make sure to include the heading, task description, pseudocode, motor and sensor setup, and program. I will include a lab sheet for you, so you will not need to print that. Just a reminder of what the lab sheets look like. If I go through my programming task sheet here, that is not it. Hold on, let me find. Okay, sorry about that. All right, so here is our programming lab sheet. Again, your team members will sign under their responsibilities. It's okay to have the same responsibility, or it's okay to mix it up a little bit as well. Make sure for project that you're going to title this Robot Drag Race. Include the date and what period you are in. Here's the illustration for the VEX Cortex. Make sure you identify where you put your motors and sensors. You're going to use no more than 2 motors in this area, and you'll more than likely use just 1 digital sensor. Let's look at some examples. So if you go online, let me turn this volume down. If you go online and you put in PLTW drag race, then you can find some good examples. Let's look at some of the VEX pieces they're using here. You'll notice in these groups, some of them are using some basic metal hardware pieces. So not in all applications would you use the base plate. Some of them are using the small wheels. There's different ways to gear this up. You can look at chain and sprocket, like you saw in that example. In this example, they're using 2 gear trains, so 2 drive motors and 2 gear trains. The advantage of using 2 drive motors is so that you have more power. If you look at their lights right here, they probably did not download that correctly because you can see some yellow flashing lights. Something there might deal with making sure that your USB is set to, or your VEX communication is set to USB only. There they got it going okay. Remember, you have to go a distance of 20 feet and then you have to stop. The sooner you stop, the better your points grade-wise will be. think about how you would program it to stop quickly. This might be some additional lines of code, not only to add a stop motor, but if you see it coasting a little bit, you might want to throw those motors in reverse at the end to stop it quickly. Notice some of the brackets that they've used to support their drive shafts. Also, pay attention to the placement of motors and the selections of metal hardware that they've made. Here's a larger one using bigger wheels. It's geared at choosing a chain and sprocket for its drivetrain. Remember, on your drive motors, you make sure that you have a larger drive gear and a smaller driven gear. However, you might get to a point where torque cannot overcome speed, so gear ratios are going to be an important consideration in this activity. So again, make sure you're referring to this task sheet, Task 2, Robot Drag Race. Make sure you're filling out the appropriate paperwork, and let's see if we can get this done in the next 3 class periods. So until next time, good luck.